f of x equals 1 and 5/10 x and g of x equals negative x plus 1 and 5/10, complete the table of values for each function, and then write polynomials to represent their sum, f plus g of x, and their product, f times g of x. Compare their x-intercepts, y-intercepts, and slopes where appropriate. Graph the coordinate pairs on the same grid to verify these attributes. Okay, so first let's start out by filling in our table. So you can fill this in manually by plugging in the x values in for x and then adding them together for f of x plus g of x and multiplying the two fx and g of x values for fx times g of x. However, I'm going to show you just how to put this into a calculator to go ahead and give us that table. Okay, so here you see I put in y1 our f of x function, 1 and 5/10 x. In y2, I put our g of x function, negative x plus 1 and 5/10. In y3, I put the two added together, so 1 and 5/10 x plus, and I just went ahead and put g of x in parentheses, our negative x plus 1 and 5/10. And then in y4, I put them both in parentheses since they're multiplied, so 1 and 5/10 x times negative x plus 1 and 5/10. And now to have the calculator do this work for us, then you press second graph or the table option there. And then notice here at -4, our first x value, then we have what f of x is in y1, what g of x is in y2. y3, if you just press the right arrow button, is -5/10, and y4 is -33. And so this is nicely done so that we have our table and we just need to go ahead and fill it out. And so I will go ahead and do that, going from x equals -4 all the way to x equals 2. Okay, so here's our table, and now we can go ahead and write polynomials to represent the sum and the product function. And so first we have f plus g of x, and we know that that will be equal to f of x plus g of x. And so then we can just plug in the actual functions for fx and g of x. So we can plug in 1 and 5/10 x plus negative x plus 1 and 5/10. Then adding together like terms, 1 and 5/10 x plus negative x equals 5/10 x, and then we still have the 1 and 5/10. Similarly, for the product function, we can go ahead and write that out, that will be equal to f of x times g of x. And so I've gone ahead and substituted in for f of x and g of x. So multiplying these, we can distribute. So 1 and 5/10 x times negative x gives us negative 1 and 5/10 x squared, and 1 and 5/10 x times 1 and 5/10 gives us positive 2 and 25/100 x. Now we can go ahead and find the x-intercepts, y-intercepts, and slopes, and we'll go ahead and use a table to organize those. And so first of all, notice for f of x that for the x-intercept, that's when y is 0 or the f of x is 0, and so x is 0 at that point, and vice versa. Since the x value is 0, then the y-intercept will be 0. And then the slope we can see from the equation is 1 and 5/10, the number in front of x. And then for our g of x function, then for the y-intercept, when x is 0, then y will be 1 and 5/10. And also notice for the sum, we can go ahead and fill in all of these y-intercepts, because for the sum function, it'll be 0, 1 and 5/10, and also for the product function, it'll be 0, 0. And note here also for the slopes that we'll have -1, the number in front of x, and 5/10. And then for the quadratic, that is not a constant slope since it's a quadratic. So we can just put NA for not applicable. And then going on for the sum function, for our y-intercept, then notice that when the sum function is equal to 0, then x is equal to -3. And then for our product function, remember that the factors that we multiplied to get the product function were just the original equations. And so, 1 and 5/10 x, well, that is equal to 0 when x is 0, so we'll have 0, 0. And then the other term, negative x plus 1 and 5/10, well, that is equal to 0 when x is equal to 1 and 5/10. Lastly, for our g of x function, we can just plug in 0 for g of x, and solving this, we can have x be positive, move that to the other side by adding x on each side. So we have x equals 1 and 5/10. So then our x-intercept will be 1 and 5/10, 0. Now in the calculator graphing this, I'll just go ahead and blow up that graph and we can go ahead and compare the x-intercepts, y-intercepts, and slopes. So one thing to point out here is that the intersection of f of x and the sum function is the same as the x-intercept of the other addend function g of x. And so that makes sense there that we'd have the g of x intercept to be 1 and 5/10. And then also notice that for our y-intercepts, that the sum function f of x plus g of x is just equal to the other two y-intercepts added together. So 0 plus 0 is 0, and 0 plus 1 and 5/10 is 1 and 5/10. And then the y-intercept of the product function is just equal to the y-intercepts of f of x and g of x multiplied. So 0 times 0 is 0, and 0 times 1 and 5/10 is 0. And then also notice here that with our intercepts of our quadratic, that they're the same as the x-intercepts of our f of x and g of x functions. And so those all line up there. And then the last thing to note here is that 1 and 5 tenths plus -1 does equal 5 tenths. And so the two slopes of the addend functions do add to the slope of the sum function here. And so those are all reflected in the graph as well with the different intercepts and slopes. And so we can go ahead and summarize. The completed table, graph, and chart show the polynomial representations of the functions, the x-intercepts, y-intercepts, and slopes where appropriate.